All right, so looking at notes 3.1, graphing systems of equations. What do you think it means when it says systems? Yeah. Multiple. Now, we're going to be focused on only two, all right? But you can definitely graph more than two. So systems of equations. So a system of equations is a set of two or more equations that use the same variables. Have to use the same variables, guys. For a system to actually be a system, yes. They have to be the same variables. That doesn't mean we have to use the same variables every time we graph. It just means if I'm graphing these two and I want to compare them, it has to be the same variables. Okay? A linear system, if the graph of each equation in this system of two variables is a line. All right? So we're going to be looking at linear systems for the most part right now. An independent system, a system that has a unique solution. When two lines intersect, all right, it happens when the lines are on the same plane and have different slopes. All right. So independent system is always going to be where they intersect. All right. So two lines intersect. Dependent system has no unique solution. So what this means that we're going to have parallel lines, same slope, different y-intercept. Okay. And an inconsistent system is, a dependent system is when they have the same slope and y-intercept. So exactly the same slope and exactly the same y-intercept. They have infinite solutions. Inconsistent is when they're parallel lines. All right? So they'll never intersect. All right, so what we're going to be looking at first, and we won't be doing too many examples of this, guys, because we've been doing a lot of these. We'll be graphing these two functions. So what we need to do is get them in y equals form first. So for the first one, please get it in y equals form on your own. What? In y equals form on your own. That's hard. I believe in you. Each one, guys, you have to do them separately. I'm just going to give you guys a little bit more time. All right, so for the first one, what was our first step? Oh.
Subtract x from both sides.
Excellent. So you had 2y equals negative x minus 7, and what'd you do finally?
Divide 2.
Divide everything by 2, right? Okay. So it's kind of a little bit annoying. I have y equals negative 1 over 2x, and then minus, did you leave it as 7 over 2 or 3.5?
7 over 2.
Okay. And then I'm just going to make a note that it's the same as 3.5 underneath it, just so you guys know. All right. So for the next one, Brooke.
Subtract 2x to both sides.
All right, I'm going to subtract 2x to both sides. So now I have negative 3y equals negative 2x. Then what?
Then you want to divide the negative 3x.
Divide negative 3 to both sides. So I get y equals 2 over 3x. Good? All right. Now we have to graph them. Please take a moment and graph both of these on the same graph. Guys, you want to extend the points as much as you can here because we want to try to figure out where they intersect at. So you don't want your lines to be curved or messed up. All right. Let's see how we did. Thomas, how'd you graph the blue one, the first one?
I'm gonna -3.5 that on the X.
So it's called the y-intercept. And this is my x-axis. This is my y-axis. Okay? So when we do the y-intercept, you're right, we do move 3.5 in a negative direction, but we move down. 1, 2, 3.5, okay? Guys, remember, whenever we plot this, you always plot on the y-axis first, up and down. Now we do the slope, and what will be the slope for this, Thomas?
Down 1, 2.
Good, down 1, 1, 2. Down 1, 1, 2. And I'm going to do a bunch of these. And I'm going to go up 1 and to the left 2. All right, that looks good so far. Guys, these are equal signs, so you don't have to think about it. It's just a solid line. Next one. Let's go with Sarah.
So.
Dotted 0, good. The y-intercept here, guys, it might not look like anything's being added or subtracted here, but we always remember that it's 0 if nothing else is there. Okay, continue. Good. Up 2 to the right 3. 1, 2, 3. Now, if I'm looking for where they intersect, guys, I should know I don't have to keep going this way. It doesn't really matter anymore. I need to go this way. All right, and hit the other line. So I'm going to go down 2, 1, 2, 3. Oops, not that. 1, 2, 3. 1, 2, 1, 2, 3. 1, 2, 1, 2, 3. And draw a line connecting the dots. All right. Now, based off my line, where do I see that they intersect at?
-2,
-1, 2, 3, -2. And then that's my solution. Guys, your solution is where they intersect, where they collide. Questions? All right, do the next one. All right. So let's go with Nick. How do we do?
I subtracted 2x.
Okay. So you got y equals negative 2x plus 5?
Yeah.
All right. We'll graph that one right away. So tell me how you graphed it. Did you graph it already?
Yeah.
Okay.
You go up 5,
1, 2, 3, 4, 5. Okay.
and then you go down 2 and over 1 to the right.
All right. So this is the first one I'm graphing. I'm going to do a lot of points because I don't know which direction they're going to intersect at yet. And I'm going to draw a line connecting them. All right. Let's see. Tristan, next one.
So I added x.
Okay. So you add x to both sides. Oops. Oops. So 3y equals x plus 2. And what's your last step?
Divide
To everything, right? Okay, you guys are getting good at this. Y equals 1 over 3x plus 2/3. And 2/3, I'm just going to put it down here as a reference, is 0.66 repeated. Okay. Guys, sometimes plotting is easier if you look at it as a decimal. You never change the slope to a decimal, though. Never change the slope to a decimal. All right. Tell me how to plot it. What did you do for 0.66?
I just put it in. Yeah, I didn't get out of it.
Okay, well, where do you think you would put it here?
You get a 0.
So 0,
Get
and
close to the 1.
there you go. But closer to the 1 because it is closer to 1. So that's where I'm going to plot my first point. Now my slope is 1/3. Right? If I went down 1 and to the left 3, that would put me there. And I realize that that's going in the direction away from the other line, so I just go the other way. Up 1, 1, 2, 3. Up 1, 1, 2, 3. Okay. And what does that look like it's close to?
2 for 1.
It looks like 2, 1, right? Now, can anybody find a problem with trying to find an intersection point when graphing? Yeah, Ryan.
Because it won't always be exact.
It won't always be exact. So that's the biggest problem with graphing. All right. It's nice because it's a good visual. It's really great when we're dealing with like sales and when things like intersect, when things higher than something else, and making a great comparison. All right. But it's really tough to find an exact point where they intersect. Good. Very good. So that's the major flaw with graphing. All right. Again, let's just talk about these systems real quick. So we'll be talking about independent, dependent, and inconsistent. Guys, an independent system, just so you know, when we get them both to be y equals, they're going to have different slopes. That's the key to an independent system. Different slopes. Okay? Different slopes. The key for a dependent system, same slope, same y-intercept. All right? And for an inconsistent system, it is same slope, different y-intercept. All right, for some people, having this written down as a reference really helps. All right, because we'll just be labeling systems off of that. Again, independent is different slopes. If they have different slopes, they'll always intersect somewhere. Dependent is same slope, same y-intercept, which means they're the same line. They're basically right on top. Well, they are right on top of each other. And then inconsistent is parallel, same slope, but different y-intercept. All right? So we're going to classify all of these without having a graph. We're going to know if they intersect, if they don't intersect, or if they're the same line from solving these via y equals. All right, we'll do the first two together, and then you guys do the last two on your own. So looking at my first one, I don't have to do any work for y equals 2x plus 3 because it's already in y equals form. All right. What I do have to do a little work for is negative 2x plus y equals 1. Savannah, what would you do first?
Add 2x both sides.
Add 2x to both sides. So now I have y equals 2x plus 1. Okay. Now we have to look and see what it has. So again, we're looking to see if they have different slopes. Do they have different slopes?
No.
No, so it's not independent. Then we look to see if they have the same slope, same y-intercept, same slope, different y-intercept. Do they have the same slope?
Yes.
Yes. Do they have different y-intercepts?
Yes. Yes.
Yes. Which one is that? Inconsistent. So the answer to this one is inconsistent. We know that these are parallel lines. Any questions on how we're going to do that? Okay. Next one. Let's go with Mary. 3x plus y equals 5. What would be your first step?
Minus 3x.
Minus 3x. So y equals negative 3x plus 5. All right. Next one. Let's go with Taylor. We're doing the 15x plus 5y equals 2. What would be your first step?
Subtract 15x.
Good. Subtract 15x to both sides. So I have 5y equals negative 15x plus 2. And then what would be your next step?
Divide 5.
Divide everything by 5. And I get y equals negative 3x plus 2 over 5. All right. What do we know is about our two equations? What about the slope? Same or different? Same. So it narrows down to two options. What about our y-intercept? Same or different? Different. So what does that mean it is? Inconsistent. All right. Do the next two. Pretty easy, right, Mary? right, Tyler.
Uh,
Do I have to do anything for the first one?
no.
Okay. So for the second one, what'd you do?
I added 4 to both sides.
Add 4x to both sides. So I have 2y equals 4x plus 6. What's next?
Oh, divided 2 on both sides.
Nice. Divide everything by 2, and I got y equals 2x plus 3. All right, Tyler, tell me what I look for. First thing you should always look for.
Slope.
Slope.
Same slopes.
Okay. If they're same or different slopes. All right. Is it the same or different?
Same.
All right. So now we narrowed it down to be dependent or inconsistent. So now we look at the y-intercept. So it's dependent. Excellent. Since they have the same y-intercept, it's dependent because they're the same exact line. Caden. First one.
Subtract x.
Subtract x to both sides. So I have negative y equals negative x plus 5. Next.
Divide everything by -1.
Excellent. And we get y equals x minus 5. Very good. Rebecca, next one.
Subtract 3.
So y plus 3 equals 2x. You subtracted 3 to both sides. Y equals 2x minus 3. All right. What do we look for?
Same slope.
Okay. Same or different slopes? What is it? Different. So what's the answer? Independent. Excellent. Thank you. Any questions on this? Pretty easy, right? All right. So for you guys, what you have for homework that you'll start doing right now, you'll be working on practice 3-1, which I handed out today. You'll be doing numbers 1 to 11 odd, and then also 15 to 25 odd.